they're pretty slow. They travel about 20 kilometers per hour, and so it takes them a long time to search. Thus, helicopters are actually used in over 90% of all searches for the tuna that are caught, wild tuna that are caught in the ocean. Here you can get a little bit sense of how the operation works. So helicopters are very cumbersome. They require a lot of effort to transport the logistics. It takes over 2 weeks to get out into the Pacific Ocean, into the wild areas where tuna are caught. And they're very difficult to fly in the ocean. They have to take off and land on these moving vessels. And during, inclement weather or when there are high waves, the vessel can actually change in height of 5 meters within 1 second. So imagine landing like a 1-ton, helicopter craft onto this moving platform that's going up and down over 5 meters in 1 second. There's actually several accidents, dozens of accidents that happen each year. And unfortunately, some of them are fatal. But this is the way that they've been using for the past 30 years to search and find schools of tuna. They're also very inaccurate. So actually, in the helicopter, they have a guy that's just looking with his bare eyes or binoculars for these schools of fish. So it's based off his knowledge and accuracy in identifying them. And lastly, they're very expensive. Helicopters cost over $2 million. And so this $2 million goes into just the helicopter cost, but you also have to have a full crew to man this helicopter, including a pilot who's skilled enough to land on moving vessels, a fish spotter that's accurate enough to accurately assess the fish school, and a mechanic to fix any problems that may happen on this helicopter. And they're spending over $300,000 a month in just gas costs. And these pilots and this whole crew has to be housed on there for months at a time. So at Valtech, we've actually developed a multi-drone AI system to replace helicopters and to augment them in the searches for schools of tuna. So our system is safer, more sustainable, and more efficient than the current solutions they have. We help fishermen find fish faster. So instead of one helicopter, you can have a drone, and actually multiple drones, up to 25 in fact. So we've designed our system to be able to handle up to 25 simultaneous drones. And we've built a drone agnostic system so that we can pair with different types of drones for different missions. VTOL, fixed wing, or multi-rotor. This is because every different fishing vessel has a different setup. So some fishing vessels may be a little smaller and they require a VTOL platform. For our fixed wing partner, they actually use a catapult launch and a net catch, so it requires a lot of space. Here you can see some of the partners we've already integrated with, a VTOL partner here in Taiwan, and a Spanish company that has the catapult launch and net caught system. So this catapult launch system is actually great because this drone can fly for over 8 hours. And so for our system, we've actually developed the software and command and control system for these drones. We built an LLM into it so it can identify all the pertinent information for the fishermen, such as identify the school with over 97% accuracy, as well as give them estimations about how many tons and the type of fish inside. So our solution is actually more efficient with a multi-drone control system where the AI in our system is able to control multiple drones, so you don't need additional pilots. And it's safer, and it's more accurate, because computer vision can achieve much more accuracy than the human eye can at much further of a distance as well. So our multi-drone searches have already proven to increase the efficiency and coverage of up to 300% more than just one helicopter. I mean, it's pretty logical. you only have one helicopter, you can only search one area. If you have multiple drones, you can search many more areas. And with our increased efficiency, we are able to reduce fuel costs. So I know this is all about sustainability, and so our system is actually really helping reduce the fuel costs for these fishing vessels. Annually, fishing vessels account for over 1.2% of global fuel consumption. That's 159 million tons of CO2 each year. And so for every 1 ton of catch, they're actually releasing 2 tons of CO2. But our system is able to reduce their fuel usage by at least 20%. And we use computer vision and AI to identify these schools, and it can actually help with the detection of IUU, which is illegal, unreported, or unregulated catches. Essentially, that's like if you catch dolphins or sharks or turtles into your nets, protected endangered species. So actually 8% of all catches result in bycatch, which is these protected animals. And this can actually disrupt the marine ecosystem as well as further harm these endangered species. And they charge up to $100,000 US in fines when you do catch some of these endangered species. And so this is very costly for these fishing vessels. And with our system, we're able to reduce bycatch by at least 30% by being able to identify these types of species in the school of fish before they go and try to catch them. So this AI-driven technology can really reduce the amount of IUU, illegal, unregulated, and unreported fishing out of the ocean. So our company is started by a couple of experienced entrepreneurs. I myself am a former US Air Force drone operator, being qualified on the Predator, the Reaper, the Global Hawk, as well as other manned assets and satellite imagery. My co-founder, he's a repeat entrepreneur with his last company making over 15 million in annual revenue. And our crack team of technical geniuses. So Jerry, our chief science officer, has actually been at NASA and DARPA, and he was there to monitor the oceans and actually launch many different oceanographic projects for DARPA. And Neil is our CTO. He's an excellent coder, has a master's in AI, and has a real expertise in computer vision itself. So at Valtech, our mission is to increase the efficiency, safety, and sustainability for the commercial fishing industry.